when we calculate the t-value, the denominator is the SE of the sample. And the SE is dividing the mean difference when we calculate the t-value. As you know, this standard error is inversely proportional to the square root of the sample size. Therefore, when the standard deviation values are equal, a larger sample will result smaller SE. The smaller standard error will result, the larger t-values. When the t-value is larger, you will more likely to reach the criteria in t-distribution. As displayed here, the three groups of people repeatedly assessed their preference of VISTA and then OSX. Based on the mean scores, all three groups are showing a very similar tendency. When focusing on the mean difference only, the first group shows the largest mean difference. However, let's look at the t-values. The t-values from the pairwise t-test yielded different results. It is plausible to guess that result was caused due to the different sizes of the samples. The third case had a sample size of 200, and therefore we can assume that the standard error of the third sample is much smaller than the standard error of the first sample. And accordingly, the t-value of the third group is much bigger than the other two. Consequently, this t-value is bigger than the criteria and therefore yielded the statistically significant difference of the people's opinion regarding VISTA and OSX. The effect size is independent from the sample size. The effect size provides an indication of the magnitude of the effect, and therefore it offers an insight whether the difference could have occurred by chance. There are several types of calculating the effect size, and depending on the statistical technique, different calculations are available. With regard to the t-test, we usually take Cohen's d. Cohen is the name of a person. The Cohen's d is obtained through this procedure. You divide the mean difference through the pooled standard deviation. In the following survey, people assessed the two operation systems repeatedly, so we can guess that the pairwise t-test has been performed. However, when we calculate the Cohen's d, we apply this equation equally for any type of t-test. And after you calculated the d value, the Cohen's d value, you can refer the following adjustment criteria. When the absolute value of d is below 0.2, the effect size is known to be small. When the absolute value of d is above 0.8, the effect size is known to be big, or you can conclude that the effect size is big. And when the absolute value of d is between 0.2 and 0.8, it is known to be medium size of effect. And first, please calculate the 3D values here. That is actually the question number 5 of a before class quiz. Based on the D values, we can add implications in addition to the statistical results. For example, when the d values of these three cases are similar, we can add an implication like the mean differences of the three groups have a similar effect size and d effect is medium. Therefore, the statistical significance is caused by the increase of the sample size. And we do not yet conclude that people prefer the OSX to the VISTA. That's actually my example. However, I think you can have different or even more creative ideas to answer or to describe this situation. So first, calculate the d values and try to formulate your own implications. I look forward to hearing your ideas. Thank you.